So in this video, we're going to talk about inverse functions. So I'm going to let R be the relation such that R is the set of three ordered pairs that I have right here. And all we have to do for inverses is we swap X and Y. So if you think about an ordered pair in terms of X comma Y, the inverse of this relation, R inverse, would be, well, I swap my X and my Y, so that becomes -1, 4. This becomes 2, -3. And this becomes 5, 0. So you might be asked to find the domain of the inverse function. Remember, the domain's your x's. So that's -1, 2, and 5. My little son commenting on that answer, he seemed pretty excited. All right, the range of our inverse, it's the y value. Those are the y's, these are the x's. So the y values are 4, -3, and 0. If you have any numbers that repeat, don't only write them one time. That's all you got to do. Now, one thing that you can notice is that if I had written out the domain and the range of R, the domain of R, what are the x's here? Well, it's 4, -3, and 0. And the range of R would have been -1, 2, and 5. So what do you notice? What happens with inverse function? The domain becomes the range, right? And then the range becomes the domain. We swap our x's with our y's. That's all we're doing for the inverse function. Okay, so the domain of the original relation is equal to the range of the inverse, and the range of the original relation is equal to the domain of the inverse. Okay, so important connections between the inverse function, right? So graphically, what's happening here is I'm taking a function and I'm reflecting it across this line, y equal to x. Okay? So if I have this function like this here, then I'm literally taking it and I'm reflecting it. If I could do, let's see if I could do it better. Well, I'm trying. So I'm trying to reflect it across, but that's the idea there, okay? So if this is f of x, this is f inverse of x there, okay? So literally the values are flipping around.